in this lesson, we are going to see how to use the computed z to find the p-value. Okay, the z, that's in a large sample, the z to find the p-value, not the t but the z to find the p-value. Okay, so to do this, solution. Now to do this, you can sketch a curve. Now the question says find a p-value for a right-tailed hypothesis test with a test statistic of z equals 1.65. Now in this particular question, they say right-tailed test, so meaning this side. So that is 1.65, isn't it? So right-tailed, so you shade the right-tailed, right-tailed, so you shade the right. Okay. Now when that is done, it means that they say right tail, meaning that you should find the area at this place. The area at the right tail is what we mean by the p-value for this particular question. So therefore, the p-value is area in the right tail. For this particular one, the area in the right tail is the p-value. So let's see how to find the area in the right tail. To do that, you take your z table, then you check for 1.65 on the positive z table. So 1.65 is here, 0.9505. There is a point here, meaning 0 come before the point, so 0.9505. Now this 0.9505, what it means is area to the left of this. So 0.9505, that's area to the left. So to find the shaded area, you need to do 1 minus the area to the left, 0.9505. So let's quickly do that. So 1 minus 0.9505, it gives us 0.0495. This 0.0495 is this shaded area, so that is the p-value. So p-value is equal to 0.0495. So this is the p-value for this example 1. Now let's go to example 2. Example 2 says find a p-value for a left-tailed hypothesis or hypothesis test with a test statistic of z equals negative 2.23. So this is a left-tailed hypothesis test. So we sketch the curve as well. So left-tailed, isn't it? So the tail is at the left. It has a left tail. Okay. So left tail. And what's the z? Negative 2.23. To find this, you can take your negative z table, negative 2.23. so this is negative 2, this is negative 2.23. so there is 3 here, 3, negative 2.23. you see, negative 2.23, so meaning negative 2.23. when you do it well, you get 0.0129. 0.0129. when you check it well, that's what you get. And this 0.0129, since you are checking a negative z-score on its own z-table, which is a negative z-table, it also means area to the left. So in fact, this area to the left already give you the what? The shaded area. So therefore, this part is 0.0129. So you've gotten the shaded portion straightforward. So in this particular one, the p-value is area in the left tail. Then what is the area in the left tail? 0.0129. so therefore p-value is 0.0129. This is a left-tailed hypothesis test. So area in the left, which is this. So that's a p-value. In fact, in this particular one, if you had checked positive 1.65 on a different z-table, which is a negative z-table, if you had checked positive 1.65 on a negative z-score, negative 1.65, you would have gotten the answer straightforward, 0.0495 straightforward. That's another way of checking that particular one. Okay, now let's look at example 3. In example 3, you are going to sketch the curve too. Now they say find a p-value for a two-tailed hypothesis test with a test statistic of z equals 2.14. Now in a two-tailed test, your p-value is 2 times area in the tail. Any tail you find, whether it's a positive or negative, the area you get for that tail, area in the tail, you multiply it by 2 to get a p-value in a two-tailed test only. Okay, so to do that, here we've been given z to be 2.14, isn't it? So let's say 2.14 is here, so we shade this part, meaning we should find the area at this tail. Now to do that, you can take your z table, then you check for what? 2.14. So 2.14, 4 is here. You should know it starts from 0, 0, 1, 2, 3, 4. So 2.1 is here, 4. So that's 0.9838. And I told you that since you are checking this on its corresponding positive z table, it means area to the what? The left. So 0.9838. So to get this area, you say 1 minus 0.9838. You get 0.0162, isn't it? So this is the area for this part. In fact, when you check it on a negative z table too, negative 2.14 on a negative z table, that's negative 2.14, you get the answer straightforward, 0.0162. you would have gotten it straightforward. But because this is a two-tailed test, to find a p-value, the p-value will be 2 times the area at the tail, the area of this tail, 0.0162, 2 times 0.0162. You get 0.0324. So that will be the p-value for a two-tailed test. Somebody will ask, why are we multiplying it by 2? Remember, they said two-tail, meaning there is two-tail which we don't know. Two-tail. So negative 2.14 is a two-tail, meaning find this tail and find this tail and add them together. So if you check negative 2.14, you would have gotten 0.0162. You are finding the total area of the shaded portion, isn't it? So you add this and this. Adding this and this gives you 0.0324, which is same as multiplying it by 2. That's why we multiply it by 2. That's the main reason why we multiply it by 2. So, but you can find just one of the tails and multiply it by 2 to get your p-value for a two-tailed test. So that is the end of this lesson. Thank you.